Welcome, sir.
You please do it. Sometimes I forget. Huh? If I forget, then you make it remember me. Okay, look, Azmain, you are not talking. You are not responding. Look, for you, I am repeating. Here, yesterday we had the magnetic field, and it was in a place, right? Look, when we are starting the wire to move at the beginning, the field lines we are getting. When we are in the middle, we are getting more field lines. If we are going up, then field lines is again less. So when we are getting the current or EMF, it depends on the density of field lines. That is called magnetic flux. Okay. So if the magnetic flux is more, then we'll get more EMF. If your magnetic flux is less, then you will get less EMF. Can you write down it? The notes you wrote yesterday. You add. Can you see it? The diagram, are you seeing everyone? Hello? Hello? Moshe? Ziba? Aisha, are you
হ্যাঁ
seeing?
স্যার
Yes,
দেখা যায় স্যার
sir.
Are
Yes,
you
sir.
seeing the diagram?
Already, sir.
Yesterday's
এটা তো স্যার
diagram.
গতকালকে দেখাইছিলেন হ্যাঁ
Yes, sir.
Yes. So I
Sir,
am
draw to kursi,
confirmed.
sir.
Yes, I know.
হ্যাঁ
Now
মনে
you do
থাকবে
not
না
need to.
আবার
Now you do not need to draw. You need to write some information, more information. What I am saying. So you are.
স্যার আমি একটু 5 মিনিটস পরে আসি আমার একটু ই করতে হবে।
You want to come after 5 minutes?
হ্যাঁ
Why? You want to go? Okay. Go.
আমি একটু পাশের বাসায় যাব
Okay.
একটু দরকার আছে
দুষ্টু ছেলে।
Yes.
আমার
Sometimes.
পাশের বাসায় আমার বড় মামা থাকে সো আইডিকে তুই কি ভাবতেছস বাট
আস্তাগফিরুল্লাহ।
ওকে
Okay, look.
নাউজুবিল্লাহ।
Look what I
Sir,
said. I am writing some information. You write that, huh? Here on the screen. Induced EMF. Induced EMF depends on magnetic field lines density. In bracket you write magnetic flux. So you are learning some new terms. You have to remember them. I am giving you more information as much as possible so that you become confident. Induced EMF depends on magnetic field lines density, that is called magnetic flux. If magnetic flux is more, we will get more EMF or more current. Okay. Then
Sir?
another, yes, please tell me.
Magnetic flux means to them is it means the like density of the field lines.
Yes,
It means
yes,
how
correct.
strong the magnetic force is, right?
Yes, correct. The more field lines you are getting, that means magnetic force is more. Okay.
So if there's more magnetic force, we get more current or EMF.
Yes, correct. Then we have some other things we are going to discuss more. This information, if you are done, then we will go to that. Are you done with this?
Yes, sir.
Yes, sir.
Sir,
Yeah, yeah, do it.
sir,
Yes,
what about the
please.
thickness of the wire?
Thickness of the wire, actually, we are not bringing here. Thickness of the wire also there is working, but it's not affecting that much. But this thing, the magnetic field is stronger, or if you are using more number of turns, then also we are cutting the magnetic field lines more, right? If we have more number of turns, then wires are cutting more magnetic field lines, right? That's why also we
Yes.
are getting more EMF. Then we have also that movement of the wire. If the movement of the wire is faster, that time we are giving more kinetic energy, right? Isn't it?
Yep.
So when we are giving
Yes.
more kinetic energy, we will also that time get more, EMF this way. This way we are getting some information now. We are having this information from your textbook. Here I'm sharing again your textbook. Yes. So this idea came from Faraday, Michael Faraday. You just write the heading.
Can you
Faraday's law of induction. Faraday's law of induction. Can you please write?
Yes, sir.
Please do it.
Sir, doesn't this experiment have something to do with cage?
Sorry.
Nothing.
Okay. Faraday's law of induction. Did you write? Okay. After writing this, you just listen to me. What is the law I am saying you? Then I will show you the definition also. Then you write. Now you just listen. Look, here we have opposite of the activity we did yesterday. Now we have a coil here, right? You see solenoid, a coil of wire that is connected to one galvanometer. We can also connect it to a voltmeter or ammeter, but we are now connecting with galvanometer. Galvanometer only gives the deflection, right or left. Okay, it's not measuring the current, it's only uh, detecting the existence of current, galvanometer. Okay, that is there any current present or not? It's only doing that one, galvanometer. Now what is happening here, if we keep the solenoid in a fixed place, and inside this solenoid, if we are moving this magnet, we are taking this magnet towards the solenoid, that time we are getting deflection in the galvanometer. Are you clear what I said?
আরেকবার
Aisha?
একটু বুঝান স্যার।
Yeah, when we are taking this magnet towards the solenoid, we are taking it inside the solenoid. It is hollow, right? The solenoid is hollow. So we can take this we can hold this magnet and take north pole inside the solenoid. So when we are doing that, then we will see that the galvanometer is giving deflection. Is it clear?
What do you
Hello?
mean by
ওকে
deflection?
স্যার।
Deflection
What do you
means,
mean by deflection?
very good. There is a needle. There is a needle in the galvanometer. That one is moving right and left. Okay. Normally it is in zero position in the middle. And when there is any current flowing through the circuit, that time galvanometer moves right and left. Is it clear?
হ্যাঁ স্যার এতক্ষণ কি করাইছেন?
To show
Is
where
it?
the current is going, right?
Yeah.
অনেক
To
কিছু
show
মিস
the
করছি।
direction of the current.
So that we
একটা
can
একটা
understand current is
কি
going
মিস
on.
করছি? মশি পিকতলে পাঠায় দেয়, এক্ষুনি ইনস্টাতে পাঠা।
স্যার লিখাই নাই,
Okay.
লিখলে তোকে তো তুই নিজেই লিখবি।
লিখে নেই কোনো
Okay.
কিছু?
Aisha,
না, খালি বুঝিয়ে
Aisha,
ও তাইলে যায় আসে না, বাদ দে।
Aisha, did
Yes,
you
sir.
understand now?
No, like it goes left or right. So
Yeah,
does
it
it show the
depends.
direction of the current?
Yes, yes. It depends. Like
Okay.
sometimes, if you are taking this inside the wires, inside the solenoids, that time you are getting right. Okay, because you are getting the EMF in one direction. When you are taking out the magnet, that time you are getting the opposite, direction of the EMF or current. That time you are getting the deflection in opposite side. Is it clear now?
Okay.
Okay, now we are going for writing the law, the Faraday's law of induction. In our next page, it's available. You already wrote the heading. Adnan, Adnan, you write the
Yes, হ্যাঁ, yes
write
স্যার,
the
বলেন
point. You
স্যার।
write the point. That is Faraday's law of induction. Write a
সাইডে,
yeah,
ওকে।
Faraday's law of induction. Here is you see in the shaded region it's written. The
আচ্ছা, আইডি
EMF.
যেটা আমার মাথায় কেন আসছে। আচ্ছা
Yeah,
মশি,
yeah,
বল।
write it. Can you read it?
ফ্যারাডে নামটা
Adnan,
বাংলা করলে মনে হয় না ফরিদ?
Adnan, you read it. Read, then
কোন
you write.
পার্টটা?
Yes, the top one. Yeah, Faraday's law of induction.
The EMF
Faraday's law of
electromotive
induction.
force.
The EMF electromotive force generated in a conductor is proportional to the rate of change of magnetic flux linking the circuit. আচ্ছা আমার পাশের বিল্ডিং এ কনস্ট্রাকশন হচ্ছে স্যার, মাইক অফ করে রাখা বেটার।
Okay, so
Sure,
the
ma'am.
EMF or electromotive force, or in here in slash you can write current generated in a conductor is proportional to the rate of change of magnetic flux linking the circuit. Already you had the definition of magnetic flux, right? So you understand what is called magnetic flux. Magnetic flux means density of magnetic field lines, and from this you finish writing the Faraday's law of induction, then we'll go to the diagram again.
স্যার লেখা শেষ।
Okay, look here, the law is saying you that
So লেখা শেষ করি নাই।
okay, you finish writing, yeah.
লেখা শেষ।
Okay, very good. All are done, right? Now look, here when we are taking the magnet towards the coil, that time there is change in magnetic flux. So they are saying the rate of change of magnetic flux is directly proportional to the induced EMF. That means if you are moving this magnet faster, that time the rate of change of magnetic flux is faster and you will get more EMF.
স্যার
If you
গ্যালভানোমিটার কি জানো?
galvanometer is a device which one is detecting the presence of current. If you want, you can write it.
ও আচ্ছা, বুঝছি।
Just is detecting the presence of current, but it's not measuring how much current is there. That is done by ammeter.
কারেন্ট থাকলে একটা লাইট টাইপের জ্বালাবে, ওইরকম টাইপের কিছু একটা, মানে একটা সিগন্যাল
Yes,
দিবে।
there is one needle here. It's the needle is deflecting right or left. That's showing the existence of current. Okay, so here we are having the magnetic flux change. If you are taking this magnet closer to the coil, that time we are having the magnetic flux more inside the coil, right? If you are taking it far away, then magnetic field lines are not affecting the coils that much. The density of magnetic field lines are less that time. Also, we understand that if the magnet is closer, that time we are having the induced EMF. If it is far away, we are not getting that much. We are getting little bit. And the condition is you have to move it. There should be kinetic energy. If there is no kinetic energy, then magnetic field lines are not cut by the coils. Okay, you must have to move the coil. There should be movement. Otherwise, there will be no induced EMF. So from all these discussions, we are finding three conclusions here. Can you write this? Can you please write the induced EMF depends on three things. The induced EMF depends on three things. First of all, the number of turns in the solenoid, the strength of the
দাঁড়ান
magnet.
স্যার, আগে ফার্স্ট লাইনটা লিখি স্যার। দাঁড়ান।
Yeah.
কোনটা লিখবো স্যার এখন?
Yeah, you write the point that the
অ্যানোটেট করে দেন
induced,
স্যার।
induced EMF depends on. Here it's written. From here you write.
আচ্ছা স্যার, এটা কি ওই যে ডেফিনিশন লেখার পরে লিখবো?
Yes.
ওই ডেফিনিশনের নিচেই তো। হ্যাঁ, কি লিখবো স্যার বলেন?
কি লিখবো স্যার?
Induced EMF depends on.
এটা পয়েন্ট 1
স্যার, এটা পরে স্যার, পয়েন্ট 1।
Yeah, induced EMF depends on. The first point is the number of turns in the solenoid.
আচ্ছা, এই তিনটা।
Yeah, these three, A, B, C. You write these 3 points. Did you draw the diagram?
না স্যার।
নো স্যার।
Please do it. Do it also.
দাঁড়ান স্যার, লিখে
আগে পয়েন্ট বলে দেন।
Yeah.
সেকেন্ড পয়েন্ট কি
লিখাই
হবে?
তো আছে, এই যে দেখ সামনে ব্লু
ওই যে
কালার ইয়েতে।
ম্যাগনেট, the strength of the magnet.
The strength of the magnet. I already told you about the
আচ্ছা স্যার, এন্ড
density.
কেন আছে? এরপরে তো কিছু লেখা নাই
Which one?
স্যার। এই যে ম্যাগনেটের পরে এন্ড,
And
তো
this
ওটা কিছু লেখা নাই।
and c the speed with which the magnet is plunged ওটা।
after and we have another point. C.
আল্লাহ, এরপর অ্যাডম্যাথস আছে, অনেক লিখতে হবে।
So please draw it.
Mizan, sir.
If you draw it, it will be easier for you to remember it.
এটা কতবার আঁকছি, এটা মুখস্থ হয়ে গেছে না।
Please draw. You will forget because here you are getting galvanometer also, a new device.
ওই তো এই সিম ডায়াগ্রাম অনেকবার এঁকেছি।
Please draw it again.
Done, sir.
Do it. If you are done with this, we are done with learning outcome B also. So learning outcome A and B both are done. Adnan, did you write about magnetic flux definition? I gave.
নো স্যার, মসিতে বললো কিছু লিখার নাই।
So
আরে ওটা তুই ছিলি, তখনই লিখাইছে।
ওই লিখাইছে না, আমি মন ছিলাম না।
ছিলি?
no, most probably he was not there. You take it from them.
আচ্ছা, আমি বলি, তুই লিখার নে।
কি ওইটা কি বললি?
Induced
You just
EMF
send
on
the-
magnetic
send the
field
picture.
lines.
Send the picture in group. That's it. He can get it.
Okay, sir.
So are you done with drawing?
হ্যাঁ স্যার, শেষ।
All of you done? Jiba is not talking. Jiba, Azmain,
মেবি মাইক নাই
Azmain.
স্যার আপনি চ্যাটটা ডিসেবল করে রেখেছেন কেন ওইখানে অন করেন স্যার অনেক কিছু মাইক চলে যায় মাঝে মাঝে
আপনি
Chat.
এভরিওয়ানে আর নিজের কাছে এনেবল করে রাখেন তাহলে, অথবা ডাইরেক্টলি পুরাই এনেবল করে দেন।
Okay, I directly enabled it, the chat. Okay, Azmain, Ziba, are you writing everything? They are not talking. Okay. Now you are done with this drawing.
Yes,
Hello.
sir.
Okay, if you are done, look here. We have this learning outcome.
সে পাঠিয়েছিস?
State the factors affecting the magnitude of the induced EMF. So what are the factors we got? Adnan,
হ্যাঁ স্যার,
what are the factors just now you wrote? To
ওই যে নাম্বার অফ টার্নস ইন দ্য
yes,
সলিনয়েড,
yes, yes, yes.
ম্যাগনেটের স্ট্রেংথটা, আর হচ্ছে মানে ম্যাগনেট হচ্ছে কিভাবে কত স্পিডে ভিতরে ঢুকায় আর বের
Yes,
করি,
so
মানে
these three factors. Okay. Now we are having another law, that is Lenge's law. Okay, this Lenge's law is giving us the basic of AC current, alternating current. Okay, so before alternating current we had direct current, and after getting alternating current we could make transformer. So it is a
পাঠাইছিস?
big invention in the technology, electromagnetic technology. So Lange's law, we are going to discuss that one now. What is that? I told you some of the information, just you remember them, that Lange's law is the basic of alternating current, and from alternating current we are getting now transformer. So that from the power station, the voltage you are getting with high voltage, that one we can get in our house with low voltage. In power stations we have 10,000 volt, 20,000 volt. In the grid lines we are having. Then in our house we are having only 220 volt. So it is possible by using the transformers, and this transformer only can work with AC alternating current. Without alternating current, transformer cannot work. So before using this alternating current we had only DC current, and that was much more expensive. That was not that much user friendly. We had to use the power stations or the power supply for separate houses. But now we can produce all together for a bigger area, larger area, a city, a country. And it happens, or it is possible because of this Lange's law. So we will go step by step. First you understand the law, how it is working. Lange's law, before going to the definition or the statement of the law, we are going to discussion what is Lange's law. Here you see the diagram.
Sir, what's the difference between AC currents and DC currents?
Okay, very good question. AC current means we are getting the current in our house, the main supply, the current we are getting, that is called AC current. And here what happens, I'm showing you a little bit, a little idea I'm giving you. Then we'll go for more discussion later. Here you see we have a circuit. This is power supply, and it is cell, battery. So this power supply we have positive and we have negative. Current goes from positive to negative. Okay, this is DC, huh? Direct current.
এটা কি স্যার লেন্সেস ল না তো, এটা তো এটাই তাই না, ফ্যারাডের তাই না?
No, she wanted to know about the difference of direct current and alternating current. I am only showing that one.
আচ্ছা,
Okay?
এসি এন্ড ডিসি, আচ্ছা
Yes,
আচ্ছা, হ্যাঁ হ্যাঁ।
that's why I'm explaining. So it is DC. Can you note down it, Aisha? This is direct current. The current only flows from positive to negative. Now, in AC current, we are using different symbol. We are using a symbol like this. This way. And this is power supply. AC power supply. Okay, in this power supply, what happens? Current goes in both the directions. Once current goes from left to right, that time the left side is positive. Then again current goes from right to left. That time we have right side positive and left side negative. And this way the current is changing the direction. The power supply is set in a way that current is changing the direction. How it is working, we will see it. We will see it in AC generator. When we'll draw and discuss AC generator, that time we will have this idea, how this AC is produced and how it is working. Now we having the basic idea that how the alternating current is going. So you write here AC, and it is happening in 1 second. The change of direction of current in 1
আচ্ছা
second.
স্যার,
Yes, tell me. Yeah,
স্যার মোশি আমাকে এই ডেফিনেশনটা বলছে, কিন্তু এটা তো মানে বুঝলাম না। মানে ইনডিউসড ইএমএফ অন ম্যাগনেটিক ফিল্ড লাইন্স ডেন্সিটি ম্যাগনেটিক ফ্লাক্স, ইফ ম্যাগনেটিক ফ্লাক্স ইজ মোর উই উইল গেট মোর ইএমএফ অর মোর কারেন্ট।
okay.
সেন্টেন্স উলট পালট মনে হচ্ছে, বুঝতেছি
Yeah,
না।
okay, no problem. I will let you know.
Sir, what
You
is
got
that symbol?
স্যার এটা একটু আবার রিস্টেটমেন্ট করেন, এটা তো দুই লাইনই,
which
কারণ
one?
না হলে
Which
ই
one?
হবে।
Which
মানে
one?
যে ডেফিনেশনটা মোশি দিল, এটা
Okay, you read
ভুল
it
লিখছে নাকি
again.
জানি না।
You read it again. What you read, you read it again.
Induced EMF on magnetic field lines density magnetic flux, if magnetic flux is more we will get more EMF or
Okay,
more current.
slowly. Induced EMF depends on.
হ্যাঁ ওই তো,
You wrote depends
induced
on.
EMF now depends লিখে নাই।
স্যার তখন আপনি বলেন নাই।
বলছে
You write
Sir,
it.
Induced
কখন?
সিম্বলটা কি?
Induced. Wait.
AC
One by
current
one. Come.
আরে এটা না, এটা ফার্স্ট এরটা যখন স্যার ওই যে লিখতেছিল এটা তখন এরটা,
Okay,
পরেরটা
wait.
ডিপেন্ডস অন তো
ও
বলছে।
তাহলে ওই ডিপেন্ডস ওয়ার্ডটাই পুরো চেঞ্জ করে দেন। হ্যাঁ তাহলে ঠিক আছে।
Is it clear now, Adnan?
হ্যাঁ 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 বুঝছি,
Okay.
তাহলে ঠিকই আছে।
Okay, fine. Now, Aisha, look. This one is a circle,
Mhm.
Give a circle. And inside the circle, you give S. This way, opposite, like opposite S. Okay.
A horizontal S.
Yeah. This way, just you give this way S. So it's giving us the sine wave. Okay, so AC current is also sine wave. That one you will get in A levels. Now AC, what is the basic thing? AC is changing the direction, right? And I wrote here 50 hertz. 50 hertz. What does it mean? That means the change of this direction is happening 50 times in 1 second.
Okay.
So fastly it's changing the direction. So that's it. Now you get it, and when we'll discuss the AC generator, that time we'll get a little bit more. Okay. Now
So
we are,
basically, sir,
yes.
AC current basically the current which flows in alternating directions.
Yes, which is changing the direction, huh? Always
So that
changing
means
the,
in
yes,
50 hertz means like in
yes,
1 second or like in 1 second it changes 50 times.
yeah, it's changing the direction 50 times in 1 second.
In
That
1
is called,
second.
yes,
Okay.
that is called 50 hertz. We know the definition of frequency, right? That is number of complete cycles every second. That is called frequency, right? So its frequency is 50 hertz. That means in 1 second, the change of alternating current direction is 50 times in 1 second.
Okay.
Is it clear now?
এদের কিন্তু টাইম প্রায় শেষ
Sure.
হয়ে আসতেছে।
Okay, now Lenge's
আর
law.
2 মিনিট আছে।
Now listen, Lenge's law. Now I only today discuss, and next class we will write it and you also will draw. Okay, what is Lenge's law? That one I am now describing. Look, when we are keeping this or bringing this magnet towards the coil, that time we are facing some difficulties. What difficulties? That after coming to this end, yeah, like when we are here, we are moving the magnet, and we can be able to take this magnet towards the coil. But when we are reaching here at this corner, that time the solenoid is not allowing the magnet to go more inside. So why it is happening? This one is happening due to right hand grip rule. Can you remember in topic 17 electromagnetism, we got the idea that we are having if even in our last topic we also got that discussions. In topic 22 we got that uh, right hand grip rule this way. If current is flowing through a conductor, then there is magnetic field produced, right? Isn't it? Hello? Hello?
Yes, sir.
So using this right hand grip rule, if it is not long straight wire, if it is a solenoid like this, then these solenoids are our other fingers, and if it is thumb, then in thumb we are getting north pole. Okay, it depends on the direction of current. Okay, or it depends on the direction of movement of the magnet. Okay, so if your movement is like that, now we are having the magnet's south pole is here. So when it is moved towards the solenoid, we will have here south pole. Is it clear? Hello? Hello?
হ্যাঁ,
So this south pole is repelling this south pole, and it's not allowing the magnet to go inside anymore. Then what we can do, we can take this magnet out. Huh? We cannot take it inside more, then we can take this magnet outside. If we are bringing this magnet outside, I think we cannot continue anymore. We don't have time. Okay, next class we will discuss it detail. It's very important. Lenge's law. I will start from the beginning again. Okay.
Okay,
Okay,
sir.
my dear students. Thank you so
আল্লাহ
much for
হাফেজ স্যার।
joining. Allah Hafiz.
I love it, sir.
Allah Hafiz.